Alright, we're back. This is section 5.1, problem number 8, and the question today is giving us a function f of x equals 4 to the, or x to the fourth power, and we're interested in the intervals 1 to 3. Now, the problem also tells us that we're going to estimate the area with n number of rectangles, and it happens to be 4 subintervals of equal width. So that means that our n, or number of rectangles, equals 4. Now, if we know that all the rectangles are going to be equally spaced, they're all going to have the same width. Remember, to calculate that, what we're going to take is b minus a, so the end of our interval, minus the beginning of our interval, which is going to give us the entire width of our estimate, and then we're going to subdivide it by 4, right? Because we want 4 rectangles. So b minus a divided by 4, b minus a divided by n number of rectangles is going to give us delta x, and in this case it's 3 minus 1 divide 2, which happens to give us, divided by 4. We have 4 rectangles. So it's 3 minus 1 divided by 4 rectangles. This area divided into 4 sections gives us a delta x of 1/2. So each one of these rectangles has width of 1/2. Now it tells us that the method that we're going to use to find the height of each rectangle is the midpoint method. And so we're actually going to cut these rectangles in half, and we're going to look at the points between the left and the right part of the rectangle. We're going to look right in the middle, and whatever the output at that value is, we're going to call that the height of our rectangle. So we look right in the middle of 1 and 3/2, and we find 5/4, and we plug in 5/4 into our function to get f of 5/4, and that's going to give us the height of our first rectangle. Between 3/2 and 2 is 7/4, and so to find the height of that rectangle, we're going to plug in f of 7/4, and that'll give us the height of our second rectangle, and so on and so forth. So to find the difference between the two, what you can do is you can take 1 plus 3/2, 1 plus 3/2 divided by 2 gives us 1.25. Now that's 1 1/4, which is also known as 5/4. So remember, we're always going to cut them right down the middle for the midpoint method. It's always worked for me to draw it out. That kind of helps me get everything right and arranged correctly. So now we're looking at what are we going to find for the area estimation. So for the area estimation, we're taking the Riemann sum of our of our height times our width. The width of each rectangle is delta x. The height of each rectangle is f when we plug in x sub I star, which in this case is a midpoint. And we're going to add 4 rectangles, so we start with I equals 1, and we sum through I equals 4. Alright, so how do we write this out? Well, we can, because delta x has nothing to do with this specific sum, it's constant, we can pull it up. So A is approximately, or area is approximately equal to delta x, and here we can start our sum. So our first sum is going to be f of x1, and x1 we decided was the midpoint here, 5/4. So f of 5/4. The second rectangle height is f of 7/4. The third rectangle height is f of 9/4, and these are just the midpoints, plus the fourth rectangle has height f of 11/4. And we know that our function is x to the 4. So we're going to plug in these. We know that the denominator of each of these is 4, and 4 to the 4th is 256. So since we'll have a common denominator, we know that all of these will have the denominator 256. Now 5 raised to the 4th power, because x to the 4th is 625. 7 to the 4th is is 2,401. 9 to the fourth is 6,561, and 11 to the fourth is 14,641. So now we'll go ahead and add these all together, and remember that we're multiplying by delta x, which has a width of 1/2. So our area is approximately equal to 1/2 times this expression here. So we'll simplify. And what we end up with is that area is approximately equal to 12,114 divided by 256. Now the next part of this problem, because what it's actually asking for is what's the average value of the function f of x as far as our estimation goes. Well, this is kind of an interesting concept, but the idea here is what if I picked some flat linear line, some flat linear function like this, and I called it f average. So I'm saying that this is the average value of my function f of x. Well, what if I looked across the same interval? So we can see here that all of these blue rectangles added up, and this entire red area, what if we made those equal to each other? So in other words, we're saying, what if we take f average, which is the height here, times the width. So we're finding the area of the red rectangle, which its height is f average, and its width, of course, is b minus a. And what if we set that equal to our area approximation, which is the blue area? So now we're going to say, let's set the red area equal to the blue area. And the blue area, we've calculated it to be a, right? It's this number right here. And so the idea is that if we find some value for this flat line here, of which makes this rectangle, the red rectangle's area, equal the blue rectangle's area, we have actually found the average value of the function. So in other words, between this point and all these points that are part of the graph between 1 and 3, x to the 4, all those points averaged together would give us an average value of f average, because the area of the red rectangle, now we're setting that equal to the area of the blue rectangle. Well, this gives a formula, so we want to solve for the average value. So we'll go ahead and divide both sides by b minus a, and what we'll end up with is a over b minus a. And once we get into integration, we'll see a more formal looking formula, but for right now, this will do. So b minus a, of course, b is 3, a is 1, so we're looking at a divided 2 is equal to the average value of our function. And we know that a is equal to 12,114 over 256, and now we're going to divide that all by 2. And so 256 divided 2 is 128. And then let's go ahead and well, I'm sorry about that. Let's go back. So I've got 12,114 over 256 times 2. 256 times 2 is 512. And then we can divide both the top and the bottom by 2. Gives us 256 in the denominator. And in the numerator we get 6,057. And so this is the solution for our problem. By setting the red rectangle equal to the blue rectangle, we found the average value of the function f average. So I hope this was helpful, and I'll see you next video.